that I think is worth sharing and kind of having. It's not that long of a part either. So let's okay. So what we're going to do today is we're going to review confidence intervals, which is topic 16. The last couple of days we were doing, when we were in class, we were doing tests of significance, which is topic 17. And so I was trying to, you can mix them up. So I really like to use pictures, and I just think it's essential to do these kind of problems. And I'm going to show you the difference between a confidence interval problem and a test of significance problem, because they're very similar, but a little bit different. So a confidence interval problem, first of all, on both of them, you need to test your conditions. You need to test your conditions if it's a categorical variable, you need to test whether n times pi is greater than 10 and n times 1 minus pi is greater than 10. Or if you don't know what pi is and you're using p hat, then it's the same thing. It's n times p hat greater than 10, n times 1 minus p hat greater than 10. That's for categorical variables. For quantitative variables, we're really just knowing is n greater than or equal to 30. That's what we're looking for. Okay, is n greater than or equal to 30, or is underlying population normally distributed? Either one of those means that I can use the central limit theorem. So you got to make sure that you test your conditions. All right, so we got that. I want to go to extend the page, and I'll leave that for the time being. We'll see. Okay. So for a confidence interval, which I'm going to represent as CI, confidence interval, the center of the diagram is going to be p hat. Confidence interval uses p hat. And using p hat, we can find our standard error of p hat. And that is for proportions, which is what we've been doing, is p hat times 1 minus p hat over n and the square root of that whole thing. That's going to enable us to make our 1, 2s, and 3s negative 1, 2s, and 3s. So the center is p hat, and then I'll have 1, 2, 3 standard errors and negative 1, negative 2, negative 3 standard errors. Look just like standard deviations. And then what I'm finding with a confidence interval is, depending upon what interval I want, what percent confidence I want. So let's just say, for example, I want to have a 95% confidence interval. Well, then 95% is going to be, I think, right in here. I'm going to have to find, we're going to look how we're going to do that in just a minute, but I'm going to find the z-scores for a 95% confidence interval, which are, so the z-scores are called the critical values. But what I am trying to do, okay, so this is the important part, is what I am trying to do with a confidence interval is I am trying to say I am 95% sure, or whatever percent I'm looking for, that pi, the population parameter, is within these two numbers that I get here for my confidence interval. So confidence interval, I'm starting with a statistic of p hat, and I'm finding what are my numbers here that give me a certain percentage confidence interval. And I'm saying that the actual population parameter pi is between those two numbers. I'm 95% sure of that. Now, the difference between that and a test of significance, is that with a test of significance, I'm starting with a hypothetical value for pi. I am saying, hey, I think that the actual population parameter is pi, and I think that that is equal to something. And then I have an alternative hypothesis that says, well, either pi, the actual population parameter, is greater than that something, or the actual population parameter is less than that something, or the actual population parameter is simply not equal to that something. These are my three choices for alternative hypothesis. So then when I make my diagram, again, if I pass, I have to make sure I pass the conditions so that I can use the central limit theorem. If I can use the central limit theorem, I know that the shape is unimodal and symmetric. I know that the center is going to be pi. My alternative hypothesis. And then I'm going to have my actual p hat. And I am going to find out, well, how many standard deviations am I away from pi from my hypothesis? How many standard deviations am I away with my p hat? And when I determine that, I'm going to get a number that I'm going to get a z-score, and I can determine what this percentage is right here. And then I compare that to the alpha that I'm looking for, which is, usually, it's usually like a 5% or maybe a 10%. I'm trying to find out, like, if it's 5%, which is pretty typical. I'm trying to find out, well, is my p hat, given the fact that I have a hypothesis of pi, is my p hat, is it a greater than 5% probability, or is it a less than 5% probability? And that's going to tell me whether or not I can reject the null hypothesis or not. The big difference here that I'm really trying to emphasize is that with confidence intervals, I'm starting my diagram with my p hat, with my statistic. With a test of significance, I'm starting my diagram with a hypothetical value for pi, for the population parameter, and then I'm comparing that to my p hat. Okay, confidence interval, topic 16, test of significance, topic 17. Okay, that's the difference between the two. All right, we're going to stop recording.